Alright, CNT 125, we're looking at our subnetting problems lab. First one we looked at manipulating our subnet mask and borrowing the bits kind of thing. I'm leaving that handy because I want my place values handy. This lab we're now going to take that step further and start coming up with, we need a chart of numbers that are going to represent the subnet numbers, usable hosts, and broadcast addresses. We need that because we need to know what our subnet numbers are and broadcast addresses are, because we cannot use them in the network to assign to things like printers, servers, desktops, that sort of thing. We need this list of usables because those are actually the addresses we can assign to workstations, printers, that sort of deal. So, let's take a look. I'm going to walk through this first problem with you. The crazy guys, cable company needs their network subnetted to help organize their network. They need at least 5 subnets for their network. That's the key. And we're dealing with a 195, so we're dealing with a Class C network. So Class C network right off the bat, we should be thinking stuff like 255, 255, 2550 is the normal. This is our bit count, dotted decimal address, etc., or dotted decimal subnet mask. We should be thinking all those things normal. Alright, but we need 5 subnets. So if I look back to my previous lab, 5 subnets right here. 4 subnets is not enough. 5 would be accommodated by this. So if we borrow 3 bits and get 8 subnets, we will have enough. So we are going to borrow 3 bits to do this. So I'll put a note in here that we're going to borrow 3. When I do that, I might as well come over here and say, okay, if I borrow 3 bits, this is going to happen. 1, 2, 3, 3 bits borrowed there. So I have 3 bits borrowed. I have now 5 bits left for hosts. And my subnet mask will change. So with that, I need to convert this to decimal. When I do, I get 224. So my dotted decimal subnet mask is now going to be 255, 2555, 255, 224. And my bit count with that, if I take a look, 888 is 24, 25, 26, 27. 27 bits in my subnet mask. So this guy here will be /27. And again, remember the reason we need this is some operating systems and devices want the dotted decimal, some want the bit count. So I need to know both. These both mean the same thing. I need to know both. And with 3 bits borrowed, 2 to the 3 is going to give me 8 subnets. Awesome. And I'm going to be left with, well, if I take a look, I'm left with 5 bits over here. 5 bits for hosts. So 2 to the 5 is going to give me, if I take a look, 2 to the 5 is going to give me 32 addresses per subnet. So right here I will end up with 32 addresses per subnet. Of which, how many are going to be usable? 30 usable. There we go. So this right here is a grand overview of what we did in the last lab, but this is the planning we need to be able to do the next step. So now we're going to take this information and we're going to come up with a chart of numbers that are going to show the subnet numbers, usable hosts, and the broadcast addresses. So to do that, what we're going to do, let's be smart. Dealing with a Class C network, we're really only focusing on this last octet. That's the interesting octet. So if I take a look at just this octet, these 3, they're already dictated. I can't do anything to them. We're working on this one. So if I take a look at this octet, I have borrowed 3 bits, 1, 2, 3. 1, 2, 3, 4, 5 is host. So these 3 bits are the subnet, these 5 are the host. Well, what I can do is I can be smart. These subnets are going to go up by a factor of this bit value right here. So again, this last octet is where all the action is occurring. They'll call that the interesting octet. And in there, if I look a little closer, these subnets are going to go up by this place value right here, the farthest one on the right. So this is the interesting bit, if you will. That is the 128.64. That's the 32 place. So that right there, my subnets are going to go up by a factor of 32 because that's the farthest right place I've borrowed. So what I can do now is I can use all that information to my benefit and say the first subnet is going to be 0. That's easy peasy. My next subnet will be 32, and they're going to continue going up by a factor of 32. 32, 64, 96. After 96, we have 128. Oops. I'm trying to do this kind of oddly, I know. 128, 160, and 192. Those are going up by a factor of 32. There's my subnet numbers. Now I'll slide this over just because he's out of line. That is my subnet numbers. Well, if you remember, when we subnet, we're taking the 0 to 255 and breaking it up into equal pieces. This first piece starts at 0, the next piece starts at 32. So this one here has to end at 31, because this one starts at 32. This one starts at 64, so this one has to end at 63, and so forth. Okay, the next one starts, this one starts at 64, this one 96, this one here has to end at 95. Coming down here, this one has to end at 127, because this one starts at 128. This one has to end at 159, because this one starts at 160. This one has to end at 191, because this one starts at 192. Okay, and off we go. So there is my subnetting. There's my subnetting. We don't have the full 8 subnets. 1, 2, 3, 4, 5, 6, 7. I would need to keep going to get all 8 subnets, but you're getting the idea. My usables now are going to be one more than this, so we're going to go from .1, if you will, up to .30, because this broadcast address is 31, so we'll have .30. Remember, I'm doing it that way because that is the last octet. We're dealing with this octet right here. So this would be blah, 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 IP address .30, .31, .32. That's why I'm writing that way. My next set of usables are going to be, get over here. My next set of usables will be .33 the whole way up to .62, because the broadcast address is 63. Here's my next set of usables. .65 the whole way up to .94, if you will. Next one will be .97 the whole way up to .126. Okay? So there's my usables in between. So if I take a look, actually I'm going to pause. I'm going to fill some of this in, just so you don't have to watch me fill it all in. Then I'm going to come back and show you some of the connections here. Okay, just so you didn't have to watch me type it all. I finished filling in my chart. Here's all my subnets, here's all my broadcasts, and then here's all my usables in the middle. And all I was doing was one greater than this number, one greater than the subnet number, and over here, one less than the broadcast address. And now I have my usables for each of the subnets. So if I take a look now, the planning I did, I said with borrowing 3 bits, I'm going to get 8 subnets. 1, 2, 3, 4, 5, 6, 7, 8. And I also said with 5 bits left, I'm going to get 32 addresses per subnet. 0 to 31 is 32 numbers. 32 to 63 is 32 numbers. Okay. Of which, how many are going to be usable? 30. 1 to 30 is 30 numbers. 33 to 62 is 30 numbers. So the planning I did earlier, I'm seeing it all now work for me. Before I do all this work down here, the planning is letting me know what I'm going to get. So that's the first thing you need to do for these problems. And this becomes super duper important. In the next lab, we're going to take these numbers and start using them in our routers and switches. So this is kind of the next step that an admin would do to get all the numbers that are correct, that are usable for my network. All right, what we need to do now is the book talks about ANDing. So we want to take an IP address from a network here, this 195.40.25.189, and find out what subnet this belongs to. We're doing this for 2 reasons. One, this is how routers are going to function. And 2, we're going to find out that this is actually a shortcut when I start getting complex questions on certification exams and so forth. This can be a shortcut to help us figure out what subnet somebody belongs to. So what I'm going to do up here is I'm going to say, okay, this destination IP, 195.40.25.189. I'm going to do 189 this way. is going to get ANDed with, when a router receives this IP, if you will, it's going to AND it with a subnet mask. Well, here's my subnet mask. This is what we found out it was, or what we said it was going to be with 3 bits borrowed. So my subnet mask is 255, 255, 255, 224. And it's going to AND these numbers together to get a result. Well, hopefully from your reading, remember, when we AND numbers together, 1 and 1, 1 and 1 equals 1. Any other combination is going to equal 0. 0 and 1, 1 and 0, 0 and 0 is going to equal 0. So anytime I have a 1 and AND it with a 1, I'm going to get 1. It's kind of like multiplication. It's a digital logic function, but it's kind of like multiplication. So if I take 195 and AND it with all 1s, I'm going to get 195. That is not going to change. If I take 40 and AND it with 255, which is all 1s, I'm going to get 40. If I take 25 and AND it with 255, I'm going to get 25. So that all came through normal. What's going to change out here is this, because I have some IP that I don't know what subnet it belongs to, getting ANDed with a subnet mask where subnetting occurred. This is going to fall into some subnet. And the router needs to know that so it knows which port to send it out, because each port would be a different subnet, if you will. So I need to take 189, and this is where we're going to have to, remember our conversions, and convert this to binary 10111101, and I need to convert my 224 to binary 111123455, and I'm going to need to now AND them together, so I'm going to try to line them up. So when I AND them together, 1 and 1 makes 1. So let me put this down here. 1 and 1 makes 1. 0 and 1 makes 0. 1 and 0 makes 1. And all of these out here to 0 is going to become 0. So we're going to end up with 1, 0, 1. 1, 2, 3, 4, 5 zeros. So 1 and 1 made 1. 0 and 1 made 0. 1 and 1 made 1. And the rest out here, all of these, ANDing with zeros are going to yield zeros down here. So this is what I get. I get 101 with the rest being zeros. When I convert that back to decimal, I get 160. Now if I slide that over now, hopefully we can get all that to line up so you can see. I'm going to get 189 ANDed with 224 is going to yield 160. And what that tells the router is 189 belongs to the 160 subnet. So now it could look that up in the routing table and know to send it out blah port that the 160 subnet is attached to. And all the work I did up here should also show me that 189, here is 191, here's 190. The usable address 189 is in this range, and it does indeed belong to the 160 subnet. Okay, so this is how the routers function. This is one of the main reasons I'm having you do this. This is how the router functions to find out what subnets or networks something belongs to. The second reason I'm having you do this is a really valuable tip when you're given, certification exams love to give you questions of this IP address belongs to what subnet? And you get all panicky. Well, I know these first 3 octets I don't need to AND, just AND the last octet with a subnet mask. And they'll give you a subnet mask like this, /27 kind of thing. Do that quick ANDing on the last octet and bada bing bada boom, you got it made. Okay? So it's a real handy tip to find, solve one of those certification questions that are throwing you a curveball. It's also a quick way to help troubleshoot in networks too. All right, that's your first subnetting problem. I'll come back in the next podcast with one of the other ones. I'm not going to do them all, but I'll do one more with you.